All right, everybody, welcome back. Hope you guys are ready to do the next questions on the FRQ for 2017. So for this part, we cannot use a calculator. So everything we do here has to be paper, pencil, and our brains. Okay. Question 3. We have the graph of the function f consisting of 3 line segments, a quarter circle, and we know that g is the function of the antiderivative of f. Okay. So because this is the graph of f, this is basically the graph of g prime. Find the average rate of change of g from -5 to 5. Easy question. Average rate of change is a math 1 topic. G of 5 minus g of -5 equals, no, over 5 minus -5 equals. Now for this part, you're going to have to figure out what g of 5 and g of -5 are separately. So g of 5 equals the integral from 1 to 5 of f of t dt. And if you look at your graph, then we have a triangle, 2, 3, 4, 5, and we have a rectangle. So it's going to be 1/2 base 1, 2, 3, 4 times height plus base times height. So we get 12. Okay, 12 minus. Now the integral, no, g of -5 equals the integral from 1 to -5 of f of t dt. Or you can think of it as the negative integral from -5 to 1 of f of t dt. And when you think about the integral from -5 to 1, you do have to take negative area into account. Okay? So the integral itself is a triangle, a quarter circle, and then we have another triangle. So we have 1/2, 1, 2, 3, base times height, 1, 2, 3, 4. I'm going to go ahead and put -4, so that already takes care of the negative area. Plus 1/4 pi r squared. And for the r, I'm going to use, well, I guess if I use a negative, it wouldn't matter. R squared. So just make sure the area is negative. Plus 1/2 base times height for the last little triangle. And this is going to be, let's see, -12, -6, minus 4 cancels with the 1/4 pi, minus the 2 cancels with the 2, minus 1. So this equals -7 minus pi which equals 7 plus pi. That's what the integral is, right? But that's what g of 5 is. So make sure you put it in parentheses here and put 7 plus pi. So this becomes 5 minus pi over 10. And that's what the average rate of change is. Okay, maybe the question wasn't as simple as I thought, but I mean, at least you get a point off the bat by doing g of 5 minus g of -5 over 5 minus -5. Okay, part B. Find the instantaneous rate of change of g with respect to x at x equals 3. Okay, well, let's start with what we know. We know that g of x equals the integral from 1 to x of f of t dt. So the instantaneous rate of change is g prime. But when you take the derivative of an integral, you cancel it out, and then you plug in the variable f of x, and then you multiply it times the derivative of that variable, which in this case is just 1. So then g prime of 3 equals f of 3 times 1. And if we go up to the graph, 1, 2, 3, we can see that f of 3 equals 4. So then g prime of 3 is equal to 4. Okay. C. On what open intervals, if any, is the graph of g concave up? Justify your answer. Okay. Since we're talking about concavity, that means we have to deal with the second derivative. We already know that g is the integral of f. G prime is f. So that means that g double prime is f prime. So if g is going to be concave up, that means that g double prime, which is f prime, has to be positive. So then we have to figure out where f prime is positive. Looking at the graph, I want you to focus on the slope. The slope is positive here, negative, positive, and 0. So it looks like it's going to be from -5 to -2, and then from 0 to 3. G is concave up on the intervals from -5 to -2, and also from 0 to 3, because g double prime, which is f prime, is positive. In other words, f is increasing, right? The slope of f is increasing. D. Find all x values on the interval from -5 to 5 at which g has a critical point. Classify each critical point as the location of a local min, max, or neither. Okay. Since g equals the integral of f and then g prime is equal f, and to find the critical points, we have to make g prime equal to 0. Then we're looking at the points where f is equal to 0. That would be -2 and 1. Okay. So this happens. G prime, which equals f, which equals 0, happens at x is equal to -2 and also 1. Okay. Well, now let's figure out what's going on before them, right? At x equals -2, g has, let's take a look. Let's erase these symbols right here. Okay, at -2, the velocity of g is negative. So then that means g was decreasing. It stops, but then it's still negative, so it continues to decrease. So at x equals 2, g has neither a min or a max. Since since g prime doesn't change signs. At x equals 1, g has a a minimum because you go from decreasing to increasing. G has a local minimum because G prime goes from negative to positive. That's it. Perfect. Moving on. Question number 4. The function f satisfies f of 0 is equal to 20. That's an initial condition, guys. Okay, underline it because we might have to use it. The first derivative of f satisfies the inequality that 0 is less than or equal to f prime, and f prime is less than or equal to 7 for all x in the closed interval from 0 to 6. Okay. Selected values of f prime are shown in the table above. The function f has a continuous second derivative for all real numbers. Use MRAM with 3 subintervals to approximate f of 6. Okay. F of 6 equals the integral from 0 to 6 of f prime of x dx plus 20. Even though they want us to use an MRAM is just basically a strategy for us to calculate an integral, right? So I want to make sure I write my integral because that's what f of 6 is going to be. The 0 and the 20, they come because it's my initial condition. So we don't necessarily start at 0, right? We already start with the value of 20. And 20 is the value of the function f, not f prime. So again, keep that in mind. So MRAM, we're going to have to use base times height, right? With 3 subintervals. Okay, my first subinterval is going to go from 0 to 2, then from 2 to 4, and then from 4 to 6. So again, we're going to use base times height. So the base is 2 minus 0 times the height, which is we're going to take the midpoint, f prime of 1, plus 4 minus 2 times f prime of 3, plus 6 minus 4 times f prime of 5, and at the very end, we're going to go ahead and add 20. Oh, I had 20 in my mind. So 2 times 3.5 plus 2 times 0.8 plus 2 times 5.8 plus 20. 7 plus 1.6 plus 10, 11.6 plus 20 equals 8.6 plus 31.6, which equals 3940.2. Okay. The beginning step, I use the concept where if you want to establish a function of x given a derivative, you're going to use the integral from a to x of f prime of t dt plus f of a. This same rule has already came up, I think, like at least 3 times in this test. All right. And even though they were asking us for MRAM, that's just another way to calculate the area underneath the curve, which is represented by an integral. That's why I set up my integral the way I did. Okay. Part B. Determine whether the actual value of f of 6 could be 70. Explain your reasoning. Okay. Well, f of 6 is going to be the integral. Again, same rule that I just wrote, guys. From 0 to 6 of f prime. I'm gonna go ahead and use x's because I no longer have x's dealing with. Plus 20. Now, here's the thing. We were told at the beginning of the problem that f prime, the value of f prime is going to be sandwiched between 0 and 7. This means that at the very, very most, f prime can be 7 and no more. Sure, it can be other numbers, right? It could be 6.1, it could be 3.3, it could be anything. But it's not going to go below 0, and it's not going to go above 7. So, since f prime is going to be sandwiched between 7, let's actually take the maximum value. Let's actually take 7 and use that as f prime. So then this is going to be the integral from 0 to 6 of 7 dx plus 20, which is 7x evaluated from 0 to 6 plus 20, which is 42 minus 0 plus 20, which is 62. So even if I take the absolute maximum value that f prime could be, I'm only going to get 62. So then no, f of 6 could not be 70. That's it. Part C. Evaluate the integral of f double prime of x dx. Easy points, ladies and gentlemen. What's the antiderivative of f double prime? F prime evaluated from 2 to 4. Plug in your 4, plug in your 2, and then take these values from the table, which is 1.7 minus 2, which is negative 0.3. Easy points. Last question. Find the limit. I told you guys that if you want to find a limit, you really got to basically plug in the value. But we have no idea what f of 0 is. Wait, maybe we do. Oh, we do. It's 20. So ignore that. 0.5 times 20 minus 10, you get 0 over 0. And what do we say when you get 0 over 0? Use L'Hopital's. Because the limit may not, in fact, be undefined. So then we're going to take the limit as x approaches 0, and we're going to go ahead and take the derivative. Now you can plug in 0. F prime of 0 minus 20 times e to the 0 divided by 0.5 times f prime of 0. F prime of 0, according to my table, is 4. So this gets me negative 16 divided by 2, which is negative 8. And there we go. And that concludes question number 4. I'm going to pause right here. I'm going to take a little break. And also, class is going to start soon. So I'll post the last video very soon. Thank you very much, and good luck with your studying.